Alright, in this problem, it asks us to rank the magnitude of the force that the bottom block 2 exerts on the top block 1. This is the forces problem, so we have to do a free body diagram. Okay? So it wants the forces on, so here I can see the force on the top block. So I would try the free body diagram just on the top block. So for this one, I have the force normal, force gravity, force normal, force gravity, force normal, force gravity, force normal, force gravity. Now, force of gravity, we know that is by the earth, but what is this force normal by? The force normal is the force normal of 2 on 1. That's the bottom object below it, it's pushing up. So then this one is 2 on 1, and so on, you get the point. So there I have the force of 2 on 1, and that's exactly what I'm looking for. So now I can go through this one. This one has gravity going down, so essentially it has the 100 grams. Convert that to kilograms, but they're all in grams, so it doesn't matter. All multiplied by g. Remember, force of gravity equals mg. So essentially the one with the most mass will have the most gravity, and then in terms, this is not accelerating any scenario. So for all of these, Fn equals mg. So the one with the greatest mass will have the greatest force normal. So I would say D has the most mass on the top. That is greater than, let's see, the next greatest mass is B. Okay. Then the next greatest is A, which equals C. Right. If I had to explain this one, how I would explain it is solve Fn for all, and Fn equals mg. G is constant. Nice, so I won't even factor that in. So Fn is proportional to the mass. More mass, more Fn. In the next problem, it says rank the magnitude of the force that the table here exerts on block 1. So now, again, it's on the top table. So the only two forces we said on the top one is Fn of 2 on 1 and Fg. Now the issue here is I don't see the table touching block 1. So in any of these, the table is never touching this block. So if it's never touching, that cannot be a force. Right? So here I could say that the force is all 0. Right? My explanation, other than gravity, force of gravity, to have a force must be touching. Again, we saw that the table is not touching the top box. And the last one, I can see, well, what rank the magnitude of the force that the table exerts on the bottom block. Okay? So again, I care about the table and I care about the bottom block. Right? So if I'm doing this, I know on the bottom block I have the force of gravity, I have the force normal of the table pushing up on it, but then also I have force of gravity, whoops, I should put that a little lower, the force of gravity on, that's on the wrong object. I do the normal force of, I have a normal force here going down, so that is the force normal of 1 on 2. But then you need to go and find that normal force. You could do it, but this gets a little complicated. What I like to do is, since I have all these interactions, why don't I just look at the entire system? So now, the entire system has a force of gravity of 1 and 2. And then pushing back up on the big box is force normal of the table. Granted, that's only touching the bottom block. So if that setup works, then the force normal by the table is equal to the force of gravity of both of them. Okay? So all I have to do is do the force of gravity of 1 and 2. So in this scenario, the force of gravity of 1 and 2 equals the mass, which we would say is 400 times g as a constant. Now granted, I would change this over to 0.4, but it doesn't really matter if they're all in decimals here. So now let's clean this up a little bit. And now finish it out. This one, the force of gravity, equals 400 times g. G is a constant, so the force of gravity is dependent on, looks like the total mass. So this one, the total mass is 300, and again, this is another one, total mass is 300. So which is bigger, C and D is greater than A, which equals to B. Again, the most important part is, can we explain it? So to explain this one, I could say Fn equals mg of the system. Again, g is constant, so Fn is essentially proportional to the mass. Right? And then that's my ranking, is based off of how the mass compares. Now, we're not going to do section D because we already saw we've done all the free body diagrams for these different ones in our pictures above, so we don't need to do that again.